rotate 90 degrees counterclockwise about the origin. Okay, clockwise and counterclockwise. When I'm turning my paper towards the right, is that moving counterclockwise or clockwise? This is clockwise, ticking like a clock. Tick, 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 tick. Yes? Versus if I move to the other way, to the left, this is counterclockwise. Do you guys remember that from last year? Okay. One turn like this is 90 degrees. Do you guys agree? Two turns is what? 180. Three turns is 270. And the fourth turn is 360. Does it make sense if you go 360, you went all the way around back to where you started? Yeah. Complete circle. Yes? All right. What we're going to do is rotate 90 degrees counterclockwise. Is that turning my paper down towards the right or down towards the left? So I'm going to make how many turns for 90 degrees? One. So make a turn, and everybody should have their paper like this. Everybody with me? Is that a yes? All right, I'm going to flip it back over really quick and talking about quadrants. Quadrant 1, 2, 3, 4. This image exists all in quadrant 1, all in quadrant 2, 3, or 4. Right now it exists all in quadrant 4. Do you agree? Okay. Now I'm going to turn it the way you guys have it. And we're going to rename this. This is our new quadrants. This is 1, 2, 3, 4. This is right, left, up, down. Now which quadrant does my image exist in? Quadrant 1. So what I'm going to have you do is R prime, S prime, T prime, and Q prime. Do you guys remember using these primes last year? Yes. Yes. Okay. What I want you to do is find each one of these going through. So for example, R goes right 4 up, what is that? 1, 2, 3, 4, 5. So I would put 4, comma 5. S is right 4 up how far? 8. You go ahead and find your T prime and your Q prime. What? Okay, so nobody should have their phones out. Phones should be put away. Away. Not even your earbuds are out. Okay, labeling. Do you guys have it? Daniel, do you have them? Because I wanted to. What's your T prime? Do you guys agree with him? Good. Keep going. One more. 9, 3. Same answer? Yes? Did you guys get the same answer? All right. Questions? Do you agree that wasn't that hard? Yeah. Okay, what we're going to do after, yes?
I wasn't taught that. Like, how do you find those?
You weren't taught to turn your paper like this? No. Okay. It doesn't matter whether you were taught to turn your paper like this. Were you ever taught, just ignore everything around you. Were you taught on how to read a grid, like right up? Yeah. Okay, that's all we're doing right now. Oh. Nothing sneaky, nothing tricky. We're reading it as if this was a quadrants 1, 2, 3, 4 regular grid. And do you agree, for example, point Q would be right 9, up 3. Okay, so nothing tricky. Yeah? No. No. Okay, so far so good? We're going to take our paper, we're going to turn it back. Now, yes, this is sideways, but I don't think you have to move your paper every time. If you'd like to, you can, but you can read it. R prime is 4, 5. So go over 4, up 5, and call that R prime. What is S prime? 4, 8. So go over 4, up 8, and call that S prime. I'm going to go ahead and connect those two. What is T prime? 9, 8. So go over 9, up 8, and what is Q prime? Can anybody answer him and how we got these numbers? No one knows? Okay, and why did we turn it sideways? Because it said 90 degrees counterclockwise. Is this 90 degrees counterclockwise? Okay, let's say it was 180. If I did a 180 turn, this would now be which quadrant? 1 or 2? 2. And I would say N prime is left 3 up 3. P would be left 8 up 4. Do you guys see how that works? Okay, but it was, oh, I was reading the wrong one, sorry. But here with the 1 turn, this is quadrant 1, so it's right 4 up 5, right 4 up 8, right 9 up 8, and right 9 up 3 to get to those points. Again, if it, so just right up, so quadrant 1, they're all positive. If it had been a 180 turn, we would say left up, left up, left up, and left up. If it had been another turn, it would be left down. So it all depends on how many turns you're making. Do you guys agree? Yes? All right. So let me show you with the patty paper. If we had used patty paper,
So much faster.
no, because then you need patty paper, and if you don't have it, then you have to go to the store and buy it. So no, it's not so much faster. Okay, so it's like this, and we rotate 90 degrees counterclockwise. Do we end up with that same image? So does that method work?
Yeah.
Any of you feel like, I'd still rather use patty paper? Any of you feel like not that bad, I can handle without? Okay. Now patty paper will be available on test day. I do want to tell you this. When is patty paper nice? When they give you images. Like there'll come a time where I give you, like say these 2 images, and I won't give you that. And I'll ask you, what's the rotation? So you'll draw the original, and then you'll start to rotate it. Oh, it's 1 rotation, or 2, or 3, or so forth. That's when patty paper is nice. For now, we can do without. Questions on number 1? Okay, really quick side note. You will be doing this one on your own today. 90 degrees counterclockwise. How many turns? 1 or 2? Don't do it right now because we're going to move on. 1 turn down to the right or down to the left?
To the left.
So which quadrant is this? It used to be in quadrant 1. Now it's in which quadrant? 2.
Wait, it's counterclockwise.
Yeah?
Is it what? Oh, okay, I see. You're so lost.
Yes.
Alright, so whatever, like, the one, how it says, like, 90 counterclockwise, so whatever, like, origin is, you have to, like, put it back where it was.
Yes. At the end, you put it back where it was. After you
What
make
do
the
you mean,
rotation.
like, you put it where it was? Like, it was an origin one,
Like,
so
right
the
here?
origin one?
Okay. Initially, it was in quadrant 4. And when we changed it this way, it was in which quadrant? And then we listed all those points.
Yeah.
Put it back, yes, and then replot.
Okay.
Yes. Okay. Graph the image after applying this transformation. Guys, I do need you listening. Now, if you wanted, you can list all your vertices, 4 corners, and apply the transformation. Subtract 10 from all your x values, add 2 to all your y values, or what's the easier way of doing it? That is an easy way. It's not actually not hard, but without having to rewrite everything, what could you do with each point? My x minus 10 means to move in which direction? Left 10, and y plus 2 means to move in which direction? So could you take every point and go left 10 up 2, left 10 up 2, left 10 up 2, yes or no? Yes. And then we'll reflect across the x-axis. For now, I want you guys doing the translating. Left 10 up 2. Go ahead and do those on your own. And I'm going to call that N prime because we're working with the new image. Did I? All right, did everybody get it? Yes? Okay. Now what do? Reflect across the, which axis? The x-axis. Which one's the x? Right and left or up and down? So I'm going to reflect across the x-axis. Yes? Guys, I've already called, no, you definitely don't need pad paper. It's not even needed, not even like it's better with. It's better without. We've already used primes, the single prime, so now I'm going to use the double prime to show the reflection. So I'm going, for n, I went down from the x-axis 1, so how far up am I going to go? 1, and that's going to be n double prime. For m, how far down is m on the from the x-axis? 5, and then which way am I going to go now? Up 5, right? 1, 2, 3, 4, 5, and call that m double prime. P is down how far? So then I go up to P double prime, and Q is how far down? So then I go up 7 and call that Q double prime. Now, will you have problems like this on the test where you have to label and redraw like this? Yes, yes you will. All right, questions on our translation and then our reflection. We are not done. You guys are not packing up. Questions?
I learned something new.
No questions? Okay, next one. Describe in words the transformation used to create STU. How did we get, guys, we're not packing up. Put your phone away, Matt. How do we get from here to here? Can anybody figure it out? Reflect across what? Good job. Reflect across the x-axis. Write that down. Reflect across the x-axis. Does anybody remember how to write it in like this type of notation? I'm going to give it to you for now. We'll talk about it tomorrow. X, Y, arrow, X stays X, and the opposite of Y. Do you guys vaguely remember that notation for Math 1? We'll talk more about it tomorrow. Guys, your assignment is finishing up number 3 and doing all of the backside. Finishing up number 3. How many are on the backside? There's only 3. On block day. You'll have it done by block day.